Hello everyone and welcome to the last part of experimental techniques, which is chemical analysis, where we test for unknown chemicals. Just let us remember that an ionic compound is formed of two parts, anion and cation. Positive cation, which can be any ion of any metal, or it can be ammonium ions, and the anions, which can be non-metal negative ion or polyatomic ion like sulfate or carbonate or nitrate, for example. Now, a term we need to familiarize ourselves with is a precipitate. A precipitate is a solid formed from the mixing of two salt solutions. If you look at these two salt solutions, they're clear and they are absolutely see-through. When you mix them together, a white solid is formed. This white solid is called a precipitate. For example, if you mix aqueous silver nitrate with aqueous sodium chloride, silver chloride, which is insoluble in water, becomes a solid precipitate formed, while sodium nitrate is aqueous and is soluble in water. Now, first let us start with the cations testing, or the positive ions. They are tested by two reagents, aqueous sodium hydroxide and aqueous ammonia or aqueous ammonium hydroxide or ammonia water. All three are exactly the same thing. The cations that we have, first I have aluminum, zinc, calcium. All three give me white precipitate with the sodium hydroxide. The difference is that when you add drops of sodium hydroxide, aluminum and zinc will form white precipitate that will dissolve upon adding excess of sodium hydroxide. Excess means a lot. Instead of drops, I'll put like 5 centimeter cube, for example. A lot. Calcium, on the other hand, it will give me white precipitate with drops, but the precipitate will remain. Even when I add excess, it will remain insoluble and it will remain visible to me. Copper gives me a light blue precipitate upon adding drops of sodium hydroxide. Remember that the ions of copper 2 are basically in aqueous solutions. They are either blue or blue-green. Now, this is why the precipitate is the same color as the aqueous ions. So if I have a solution of copper 2, assume that it is blue. Just like the color of the precipitate is light blue precipitate. And the precipitate will remain upon adding excess, it will not dissolve. Chromium 3 and iron 3 both are going to give me a green precipitate with drops of sodium hydroxide. We can differentiate between them by adding excess sodium hydroxide because chromium 3, the green precipitate, will dissolve to give me a green solution. Iron 2, on the other hand, is a green precipitate which will remain and is insoluble upon excess. Iron 3 is a red-brown precipitate, the color of rust. If you look here, this is the color of iron 3 precipitate. This is the color of chromium 3 precipitate. This is the color of copper 2 precipitate. Ammonium ion is the last thing. When you add drops of sodium hydroxide or excess sodium hydroxide, you will see no change at all. How am I going to see a change? By warming. When you warm the solution, bubbles of a gas are produced and the gas will turn damp red litmus blue because the gas produced is ammonia gas. For ammonia water comes in very handy when you want to differentiate between aluminum and zinc ions because aluminum ions will give me white precipitate that is insoluble in excess of ammonia water, while zinc gives me white precipitate with the drops of ammonia water, but upon adding excess, it will dissolve. Calcium, it does not give me anything. Test of copper, on the other hand, is really, really unique because in the beginning, it gives me light blue precipitate. When you add excess, the precipitate will dissolve and give me a dark blue solution, such a very colorful solution. Chromium 3 and iron 3 are going to give me green. Iron 2, I apologize, are going to give me green precipitate insoluble in excess. The iron 3 gives me red-brown precipitate which is insoluble in excess, meaning that iron 3 gives me the same result when tested by sodium hydroxide drops and excess. Iron 2 will give me the same result whether by drops of sodium hydroxide excess or drops of ammonia water and excess. What if I added sodium hydroxide or ammonium hydroxide but there was no change whatsoever? The solution remains clear, it remains colorless, and there is no change whatsoever. I then revert to the flame test because odds are it is one of these three, either lithium, sodium, or potassium, because these three are not going to give me any precipitate, nor are they going to produce ammonia gas upon warming. So we test by a flame test, meaning we put a wire or a wooden splint in hydrochloric acid, then in the salt, and introduce it to a blue flame. Then we observe the color change. If the ion is lithium, it gives me crimson red. Sodium gives me yellow flame. Potassium, lilac. Calcium, orange red. Barium, it gives me apple green. And copper gives me blue green. See, when we said the solutions of copper are blue or green, and the cations, whether solid, are colored blue or green or solution. Now, for the anions testing, we group them, meaning each group has its own test. I have the halides. The halides are tested by aqueous silver nitrate and drops of nitric acid. Upon adding this, they will give me a precipitate. The halide, whether potassium or sodium aqueous, is a colorless and clear solution. Upon adding silver nitrate, if there was a chloride, a white precipitate is formed. If there was a bromide, a creamy precipitate is formed. If there was an iodide, a yellow precipitate is formed. Now, why am I adding an acid? The precipitate is silver chloride or silver bromide or silver iodide. So, what is the need for the acid? The need for the acid is to remove the carbonate ions if present. Because if I have carbonate and I add hydrochloric acid or any acid for that matter, I'll get effervescence of a gas that will turn lime water milky. Lime water is a colorless, clear solution like this. If I add a carbonate to an acid, carbon dioxide is produced and it will turn the lime water milky, kind of like if you can see this white precipitate, or it will turn milky in that way. Nitrates are tested by sodium hydroxide and we warm and it produces ammonia gas. But the difference between the test of nitrate and the ammonium ions is that nitrate needs aluminum powder to produce the ammonia gas. Sulfate is tested by barium ions, whether barium chloride and hydrochloric acid or barium nitrate and nitric acid. In the end of the day, the white precipitate formed is barium sulfate. Sulfite, last but not least, is by adding dilute hydrochloric acid and potassium manganate 7. Potassium manganate 7, being an oxidizing agent, is reduced by the sulfur dioxide produced from the sulfite ion and it becomes colorless. Now let us agree that a test is useful whether it is positive or negative, because if I make a test of sulfate, for example, and it did not give me white precipitate, there was no change, there was a negative result, I understand by that there is no sulfate ion present. So negative result will mean absence of a specific ion. Positive result means that the ion is present. For gases, of course, I know everyone is familiar with the tests, but let us recap them quickly. Ammonia is the only basic gas in our lives, and it is tested by damp red litmus, it will turn blue. Carbon dioxide, most common test since we are in primary, and it is passed in lime water, which is calcium hydroxide, and it will turn milky. Chlorine is a bleach, so it bleaches the damp blue litmus after it turns red. Hydrogen, uh, this is the squeaky pop test. lightest splint burns with a pop. Oxygen is a glowing splint relights because oxygen supports combustion. Sulfur dioxide, like we agreed, it will decolorize potassium manganate 7, changing it from purple to colorless. Just a recap to collection of gases, that gases can be collected by several ways. It can be collected in a gas jar, or it can be collected over water in a measuring cylinder, or it can be collected by gas syringe. Most accurate is gas syringe. Remember, if you're collecting using a gas jar, that upward delivery is for light gases, the gases which are less dense than air, otherwise they won't be collected. And for the dense gases, or the gases more dense than air, they are collected by downward delivery. Last but not least, if you're solving question number 3 in paper 6 of Cambridge, or if you're solving anything related to chemical analysis, remember that if you find a white solid, it is not a transition metal, because all transition metals form colored solids and colored salts. If you find condensation or drops of a liquid formed on a tube upon warming, it means that the salt is hydrated. It has water of crystallization. If a liquid catches fire, it is a fuel. It's an organic fuel. If a liquid has an antiseptic smell, odds are it is an alcohol. And if it has a vinegar smell, it is ethanoic acid, which is vinegar. If it produces vinegar smell after warming with an acid, again, it is an organic compound. That would be more than enough. Last, if it is immiscible with water, it is definitely organic substances because they are insoluble in water. Thank you all and best of luck.